All right, the next topic that we're going to talk about is called a difference of two squares. And this is a special type of factoring when we have a particular set of items that is true. So the first thing is that we have no middle term in our standard form of our quadratic. So in other words, our ax squared plus bx plus c, there is no bx term. It's only something times an x squared and then plus a constant. The constant has to be subtracted. So it has to be a negative number for the constant. And the third thing is that each term has to be a perfect square. And so that's why this is called the difference or the subtraction of two squares, is because we are subtracting two things that are perfect squares. So it takes on the form of something that looks like this: something squared minus something else squared. And if that's the case, we don't have to go through the whole X puzzle with the T-chart and the box, the X box method that I showed you last time. We can simply write it like this: whatever A is in the front of each set of parentheses, whatever B is in the back of each set of parentheses, one with a minus and one with a plus. So again, we're looking for something in the form of a squared minus b squared. So we have an a squared here, which becomes an a in the front of each set of parentheses. And then we have a b squared as our second term, and it becomes a b in the back of each of our parentheses, one with a minus sign, one with a plus. So let's take a look at an example. So this first example has a 9x squared, that's going to be my a squared, and if a squared is equal to 9x squared, let's figure out what a is going to be. So a is going to be the square root of 9x squared, because to undo squaring something, you take the square root of it. Well, 9 is a perfect square. It's the perfect square of 3. And x squared is the perfect square of x. So when I take the square root of 9x squared, I'm going to get 3x. And so I can go ahead and set up the front of each of my parentheses with the 3x. Now I'm going to take care of the b term. And so the b term had a 4. And so a 4 is going to become, let's see, my b is equal to the square root of 4, and so b is going to be 2, because the square root of 4 is 2. I need a minus 2 and a plus 2 in order to fit the pattern that we have right up here: a minus b and a plus b. So this is my factored form without doing an X puzzle with a T-chart and a box and taking greatest common factors to find it. Let's go ahead and look at number 2. I would like for you to try this one and then come back and see how you did. All right, so on problem number 2, I'm going to identify my a squared as being 25x squared. So a is the square root of 25x squared. Square root of 25 is 5, and the square root of x squared is x. My b squared term is 36, and the square root of 36 is 6, so b is 6. So I can set up my parentheses with 5 x's at the front, 6's at the back, one with a positive and one with a negative. Before we go to problem number 3, I wanted to point out something that I didn't actually mention previously, and that is that we should always be looking to factor out a greatest common factor first, if there is one. So I needed that for example 3 because I don't see a perfect square here. I see a 3, and that's a prime number, not a perfect square. But if I recognize that I have a greatest common factor of 3, I can factor that out and then see if I have perfect squares left. Factoring a 3 out of each term, and remember we learned how to do this last time, I'm going to be left with x squared minus 49. And 49 is a perfect square. It's the perfect square of 7. So now I can proceed with my technique of factoring by difference of two squares. I'm going to identify x squared as being my a squared term, so that means that a is going to be equal to the square root of x squared, or simply an x. My b term is going to be based on a b squared of 49, and so b is equal to the square root of 49, or 7. From here, I can go ahead and write my final factored form. I have a 3 because I've brought this 3 down, and then I have parentheses with an x in the front, and in the back I'm going to have 7's, one with a minus and one with a plus, and that is my final factored form.